Okay, so what we're going to be talking about now is depreciation. As we've got noted here, the estimated loss in value of assets is called depreciation. So an example that you could think about is you buy a brand new car and it costs 35 grand, and then after a year it's worth 30 grand, and then the following year it's worth 23 grand, and then following that's called depreciation. So it's a loss in value. So, after a year, the car that I've just bought for 35 grand is going to be less than what I paid for it. That's what we call about depreciation. This estimated value at any point in time is called its future value, which is what we're going to call VN in this case. And sometimes it's also called book value. So some questions or some questions you might come across, if it's referencing book value, it means future value. Okay. When the value becomes zero, the item is said to be written off, so it's not worth anything anymore. At the end of an item's useful or effective life, so for example, especially in terms of how it contributes to a company's income, its future value is then called its scrap value. And that'll be especially important when we get to the third type of depreciation here, called unit cost depreciation. So as noted here, we've got three methods by which depreciation can be calculated. We've got flat rate, which is a straight line depreciation, and its value decreases by a fixed amount each unit time interval, so each depreciation period. The second one is the reducing balance or compounding depreciation. Its value decreases by a fixed rate each month, each unit time interval, so each depreciation period, generally each year, or that's what's often given as a percentage of the previous value of the item. And I've got the third one here, unit cost depreciation. We'll get to, so what I'm going to do now is I'm going to go through flat rate depreciation, then I'll make a separate video for reducing balance. The theory for both is on this same page here, but I want to sort of go through them separately. And in that second one here, we will sort of do a bit of a comparison between a flat rate and reducing balance. And the third video will be looking at the unit cost depreciation. Now, let's look at the flat rate. The value decreases by a fixed amount. That sounds quite familiar. Just a little bit in reverse. So remember in simple interest, we have a value increases by a fixed amount each unit time interval, if you want to use those words. Depreciation is effectively the opposite of that. All right. And we're saying it's generally each year, but in this case, what we talk about is in terms of, we say number of years, but really it's going to be in terms of the depreciation, the depreciation periods, this part here. Okay. So let's have a look. Recursion equation is very similar to what we've seen. So it's Vn plus 1. So that's our, if you want to use our sort of recursion term, so that's our new term. And this is our previous, so Vn. Now the difference between this and simple interest is this sign here. In this recursion equation, we've got a minus sign, because remember it's a decrease in amount, whereas in simple interest it was a plus. And of course we have the lovely V0 there. All right, so the future value is Vn equals, so remember, so let's highlight, let's give some colors to these. So the green is Vn plus 1, that is our Vn. The purple is this Vn here, and V0. Okay. Now, so it's Vn equals V0. Remember that's our basically our principal value, minus n being the number of depreciation periods down here. Okay, we've got Vn here being the future value, and VO is the starting value. So Vn is basically what it's going to be. What value is my car worth a year after I bought it, 2 years after I bought it, 3 years after I bought it. Okay, And D is the depreciation for each time period, okay? And what we can see here, okay, so what you've got here, so we've gone through what the different terms are, except for D. D is depreciation each time period. We calculate that using this formula here. So we've got V0, so we're saying the starting value times the interest rate divided by 100, okay? And as we can see here, that gives us, in the end, I'm just trying to pick a nice color here, that gives us our future value. In a sense, it's the same equation there, but what we're saying is our cost price, V0, minus the total depreciation to that time period. So it says D multiplied by how many years? So if it's 1 year, it'd be 1 times D. If it's 2 years, 2 times D. 3 times D, etc., etc., etc. Okay? And so what you can do is you can have, your time, your depreciation each time period. So that's always going to be the same number, and use this formula to work it out. And what you end up with is this linear decay. So it's a straight line. Okay, so your value starting off at this point at where you essentially your principal, you're losing value on, say, the car or whatever it happens to be, and it drops down on linear scale. It gets to a point where it's not worth any money, or it's not worth money to the company or whatever, and so that's the salvage value, because we're saying that's it. Okay, so we're going to do a question, couple what's it called, worked examples. All right, so we've got our equations here. We've got our recursion equation there, highlighted for you. The future value again, and the depreciation, how we calculate the depreciation. So we need to find the annual depreciation. So let's have a look at the equation. Question. This printing company bought a new printing press for 15 grand and chose to depreciate it by the flat rate method. Its depreciation was 15% of the prime cost price each year, and his useful life was 5 years. So the annual depreciation part saying, here's my depreciation was 15%. That's coming into this bit here. That's coming into that R, okay, of the prime cost. So, and this is where it's saying, because you can make that link, but it's really, that's the important point, the fact that you've got depreciation. So what you're doing is you're calculating D. So D equals V0 times R over 100. So I've got V0 being 15,000 times R. R in this case was 15%, so 15 over 100, and that will give you a value of 2250. Okay. So its depreciation, the final annual depreciation equals $2,250. Okay. The next bit was to write a recurrence relation for the flat rate depreciation. So what we've got, remember our recursion equation is this, effectively this Vn plus 1 equals Vn minus D. Okay. Our Vn plus 1 stays as Vn plus 1. We go Vn here, but now we've got our value here. We've got this 2250. Okay, so 2250. Remember, because it's depreciation, it's got the negative sign there, and then we say V0 being 15,000. Okay, so you need to make sure you state what that is. All right, so V0 being 15,000. So now you've got to draw a depreciation schedule for the useful life of of the press and use it to draw a graph of the book value. Now, I haven't got it up on the calculator this time, but I'm going to show you how you can do that. And you've seen this before because we've gone through this before. So you're going to set up time, okay? And then we'll say future value, whatever future value happened, the term, you could put FV there if you wanted to. And then what you write is you're going to write 15,000. That's your V0. Then your 2250, that's your D, and your time is your N. Remember, it's Vn equals V0 minus ND. Okay? And because that's going to get the time, it's going to say 15,000 and a time 0. So that would be, this part would become 0. Then you're going to go 15,000 minus 2250 times 1. And that's 2250. So you're going to do 15,000 minus that number, and you're just going to keep going like that. Then you plot that, and you should know how to plot that as well now. And that would be your plot. So you draw that up. So in this case, you've done that. You've done that part of that question. So we're going to the last part. The last part says generate the relationship between the book value and time, and use it to find the scrap value. So looking at this last one, we're going to generate that relationship between the book value. So what we need to do is, we've got the equation we had before. We had V0 equals, not V0. We say V0 because that's what we've got, 15,000. Okay. We know our D value is 2250. We know our N. We'll come to that in a moment. We do know our N is 5 because, remember, we said the scrap value here. All right. Where we link that back up to, actually, I'm going to change colors so I can make that link a bit clearer. Okay. Let's pick the green. Scrap value and its useful life was 5 years. So that's where I can make that link. Useful life was 5 years. That's what we're talking about, scrap value there. Okay. All right, but first let's generate a relationship. We're going to have Vn equals 15,000 minus 2250n. Okay. We know that from back up here. We know that from this one up here. All right. But now we've added the D part. Okay. Now what we do is we know we want V5. So that's 15,000 minus 2250 times 5. That equals 15,000 minus 11250. That equals 3,750. Okay, so scrap value equals 3750. All right. Oops, I meant to get rid of that before. So to clean this. So, well, let's just keep it up here. Jared bought his car 5 years ago for 15 grand. Its current market value is 7.5 grand. Assume straight line depreciation, so that's a flat rate one we're talking about. The car's annual depreciation rate. As you can see, my lovely writing, this was actually from last year. We have to work that in a particular way. So what we're saying is, it was started off at 15,000. Okay. After 5 years, it's worth 7.5. So over 5 years, it's dropped 7.5 grand, because that's the 15,000 minus 7,500. That's where I get 7,500, because this is new and this is after 5 years. Okay, so it's dropped in value by 7.5 grand, which means it's worth 7.5 grand. Now, that's only telling you how much it's depreciated by. Each year, that's where I take the 7.5 grand and I divide it by 5, and that gives me 1,500. And I'll add per year. Okay. So the relationship between, so that's A, we've done A. So B, the relationship between the future value and time, and use it to find when the car will have a value of 3,000. Okay. So when we do that, let's actually, first off, we're going to go Vn. Okay. We're going to write Vn equals V0 minus ND. Oops, ND. All right. Now, if we go back up here, this was V0, all right? And this is Vn. So we know that that's 3,000. We know that that is 15,000. We know that D is equal to 1,500. And we're after N because we use to find when the car, so how long, okay? So what you need to do now is rearrange the equation. This would be a perfect place to use solve because you'd write solve in your calculator, right? Solve 3,000 equals 1,500, 15,000, sorry, minus 1,500. N, so put a bit of dot there, then put a comma, N because I'm solving for N. Close the brackets, press enter, and you'll get your N value. Okay, that's if you want to use solve. I suggest you use solve at that point. Alternatively, you're rearranging it so you're getting, everything in terms of N by itself. So what you end up with is N equals minus 12,000 over minus 1,500 equals 8. Okay, so in this case it would be 8 years. Okay, and that's how you'd work out a question like that. Okay, so the future value will reach 3,000 when the car is 8 years old. So, 3,000 after 8 years. Okay, thank you.